Today we're going to talk about scatter plots and least squares line data that has two variables in it is typically called bivariate data. And scatter plots are just a set of x and y points. And there's some relationships that we need to know about. First of which is what's called a positive correlation. So if the points seem to be grouped in such a way that they make somewhat of a rising line, we say that's a positive correlation. If the points are grouped in such a way that there seems to be a pattern that is like a negative line or a negative style grouping going down from left to right, that's negative. And then if everything's just scattered all over the place, we say there's no correlation. So if we look at these two graphs and we talk about them having either a positive, negative, or no correlation, I think it's pretty safe to say that this tends to go up. So this would have a positive correlation. And this neither goes up nor down, so this is no correlation. In this set of data right here, we see we have a positive correlation. And we start talking about a line of best fit, or a line that kind of passes through the most possible points and has an equal number or close to an equal number of points on each side that it passes through. Now, the deal with this is it's really hard to calculate this exact line. In fact, it takes a lot of technical mathematics to do that. We're going to let our calculator go ahead and do that in a few minutes. But for right now, we're going to say that that least squares line or best fit line is the line that best represents the data on the plot. So calculators can also calculate how these groupings of points relate in such a way that they resemble a line or don't resemble a line. For instance, it's known as something called a correlation coefficient, also given by the variable r. And what that does is the closer this r value is to 1, the closer your grouping of data looks like a line. So you can see this is a fairly tightly grouped increasing line, and it has an r of 0.7. This, while it increases, is more spread out, and thus the r is 0.3. If there's no correlation whatsoever, we say the r is 0. Likewise, you'll notice close to a line but not exactly a line in the negative direction gives me a negative r of 0.7, and so on and so forth. Now, a least squares regression line, like I talked about before, passes through as many points as possible and leaves sometimes an equal number of points on either side of the line, or some on one side, some on the other. However, this line is found by calculating the minimum sum of the squares of all distances from the point to the line directly. When we talk about linear extrapolation, we estimate a number outside of the data points given based on the line. So if I wanted to extrapolate some data, I would extend this line forever and ever and say, hey, way out here, there's a possibility that my x value could be one number and my y value could be another. Where if I interpolate something, I'm using this calculated best fit or least squares line to say, well, even though there's not a point right here, based on this line and my experimental data, I can say with not, total certainty, but with relative certainty that the x is going to be this and the y is going to be this. So we're going to now use some extrapolation and interpolation again. And based on this regression line here, we want to find the value of y when x would be equal to 7. So here's 7, but you'll notice I don't have any y values here. So if I take and extend this line at relatively the same slope up to the point 7, which is right around here, that's an x value. And if I move over directly horizontal from there, I can see that I'm close to a y value of 16. Whereas if I look at this same regression line and I say, well, my x value is roughly 3.5, which is right around here, there's no specific y point associated with it, but if I go straight up and straight over, once again, I'm probably, I don't know, roughly about 8.25. And again, this is estimation, but if we had an actual equation for this line, we could do our estimating a little bit more accurately. Alright, so now what we're going to do is we're going to use our graphing calculator to write an equation for a best fit line of these points right here. And if I were to graph them by hand, at 2001, I'm roughly up at 39. At 2002, I'm about 28. At 2003, I'm about 20. 2004, 16. And 2005, I'm at about 18. And I'd want to do a regression line for this set of points. Now, if I were to just randomly draw something that splits everything, I'd draw it, somewhere around here. Okay. Now, we're going to do this more accurately on our calculator now. So our first step is to do the following. We want to hit the Stat button, which is right here, and we want to edit. So we'll hit 1 or hit Enter. And you'll notice I have a bunch of numbers in here already. Now, if your list is the same, we're going to want to clear those lists, and the best way to do it is to move up to the top heading of our column, hit the Clear button, and then move back down. And you'll notice that list has been cleared. I'm going to move over, go up again to the heading, hit Clear, and go back down, and now you notice both lists are clear. I'm going to type in 2001, move down, 2002, 2003, 4 and 5. And then next I'll move over to the other column and type in my numbers there. And like magic, they're all in. So the next thing we want to do is we want to take and go ahead and graph this on our calculator. Now, this isn't totally necessary to write the equation, but it does give us an idea of what this line looks like. So let's go ahead and do that. What we're going to do first is we're going to go up to Stat Plot. Now, this is in blue, so we have to hit second, y equals. And you'll notice here it says the plots are off, so I'm going to hit number 1. Turn my plot on by taking that little blinky guy and going over to the on button. And then you'll notice here I have a whole bunch of different graphs I can choose. I want this one, which looks most like a scatter plot. So I move down and I hit Enter. And this is going to tell me that X is my list 1 and Y is my list 2, and I'm going to mark those points with this little box right here. If I were to now hit Graph and look at my screen, you'll notice I see nothing on there. Well, chances are that's because I don't have my window set right. And I want to see years from 2001 to 2003, etc., etc. So if I want to see all those years, then it might be a good idea to change my window. So I will take, and right now my window goes X's going from basically -10 to 10. If I want to see 2001 to 2005, all right, then I'm going to take and make my minimum value. I'm just going to go, how about 1990? Then I'll make my maximum window 2010. And then my Y values are going from basically 18 to 39. I'm just going to go 0 to roughly 50. And with these values for my X's and Y's, I should be able to see a graph and points now if I hit Graph. So I'll go ahead and do that, and there they are. Next, what I want to do is I want to calculate a line that's going to go through these things. So if I look at that, that line's going to go up this way, I would think. All right. And now I'll take and do that by hitting my stat button. I'll move over to calculate by hitting this arrow. And then calculating this linear regression, number 4. You'll notice this comes up on my home screen, and now I have to hit enter. And what it does is it calculates my slope and my y-intercept with an r value in this case. So this is pretty linear because it's negative and it's 0.9, which is close to a line. And at this point, I'm going to write down this equation of a line. So it's negative y equals a negative 5.84, I believe that was, or negative 5.4, x. Let's look at my y-intercept again. My y-intercept in this case is going to be, looks like 10,840.4. 10,840.4. So, if I look at that and look at my graph here, it doesn't seem very consistent because it says we only have 40 cases here. All right? And you'll notice that the graph that we just drew looks a little bit different. And this is in large part due to my scaling. You'll notice here that I'm going from 0 to 2001. There's basically, if I start at 0, I've got 2,000 numbers between this and my y-intercept. So these x's and y's don't really make a lot of sense in this graph. So let's go back to our calculator, and we know that our graph, again, looks similar to this. I see a very steep slope, and this is my equation. What I want to do is I want to put my line in this scatter plot, if you will. To do that, I go back to y equals, I hit vars, then I'm going to go down to statistics, which is number 5, move over to equation, and then hit regression equation. And you'll notice that equation of the line is now plugged into y equals. And if I hit graph, you'll see I've now graphed a regression equation. Notice it's hitting kind of 2 points. I got a couple points on one side, couple points on another, and this is my least squares line. You'll notice that the y-intercept is 10,000 and not somewhere around 40 like it appears to be in this graph. Our calculator is the most accurate. Now this problem asks us to take and predict the number of botulism cases in 2008. So this is going to be an extrapolation because it deals with numbers outside what we already have in our sample set. So if I want to do that, I go about using my table to find that number. So once again, I've plugged my equation into this y equals. If I move to table by hitting second and graph, you'll notice my table is not populated with a whole bunch of numbers. Yours might be. And that's because of the way you've got your table set. So if I hit second and table set, I have some options here. You'll see how mine's set up. I have my table start. This could be any number. My delta table, that could also be any number. The important thing is this independent variable, which is x. And I have it set for ask. So that's what I'd like you to do, is set that for ask. And then let's go back to our table. Now, these numbers for x, I can plug in anything I want. And in this case, I want 2008. So if I hit 2008 and hit enter, my y value is going to be roughly negative 2.8. So let's pop that in. So it seems to make sense in this extrapolation that this line would be going below and possibly being at -2. I'm not sure this totally makes a whole lot of sense because we can't have negative botulism cases. We could get rid of botulism as we go further and further into our future, only because, health and food service get much, much better. But I'm not sure this -2.8 is a totally realistic number, although this is what happens after we calculate our regression equation and then use that data to extrapolate some more information. Let's move on to another example. So here's our next example. And what we're going to do in this case is we're going to do our table calculation and our window a little bit different. You'll see that just like the other problem, I have some years listed and I have some numbers listed. We're going to still plug these into our calculator, except this is still our x and our y value. But as our x value, if we read this right here, it says let x equal the number of years since 1990. So since 1990, this is 0 years. Whereas this is 4 years, this is 8 years, and this is 12 years, and this is 16 years. So these are my new x values that I'm going to plug into our table. So let's fire up that calculator again. And once again, we'll go to Stat, we'll go to Edit. Now you've got those previous numbers in there, so go ahead and clear those two lists. And then in L1, we're going to plug in our x values of 0, 4, 8, 12, and 16. And in L2, we're going to plug in our y values as listed in this chart. Once we've done this, we're going to want to set up our window appropriately, going from, let's say, -5 to 20 for my x's so I can see everything. So let's go ahead and do that. Go -5 out to 20. And then my y's, I can probably go from, I'd say, 250 being our lowest y we want to look at, to probably, I would say, 1200. Because that exceeds my 1085. Then I'm going to take and see what this graph's going to look like. And it looks somewhat linear but curved. And when we draw our best fit line, it should go somewhere through here, but I've got to calculate what that line is. So in order to do that, I'll hit Stat again, go over to Calculate, and hit number 4, linreg, and get a value for that, which in this case is 49.7x plus 175.4. So I have, once again, y equals 49.7x plus 175.4. And now if I were to take and graph that, I go back to my calculator, go to y equals, next go to vars, stat, equation, reg equation, there's my line, go ahead and hit graph, and you'll notice that line splitting that curve, and there we have our general graph. Now you'll notice once again that we wanted to find out what would happen in the year 2000, which is within our data. So we're using interpolation. So once again, we're going to hit Second, Table, and we wanted the year 2000, not 2008, but these numbers don't reflect the exact year. They reflect the amount of years after 1990. So 2000 is 10 years after that. So I'm going to plug in the number 10. and get a y value by hitting enter, and I would get 672.4 contributions. So hopefully that makes some sense. Practice it a couple of times with the examples I've given you to make sure you can duplicate the results. Do the assigned problems from ConnectEd, and we'll see you tomorrow.